called find factor, you can specify we have a bi-val parameter n, but the type of this parameter has to be an integer. If you try to specify a true-false value for the find factor for parameter n, it should come back and say, I don't think so, because we cannot find a factor of true, we cannot find a factor of false, because they are not integers, they are not numbers. For the same reason, we can also associate a type with the return value. So basically, we can say, when we return a particular value, the return type of find factor should be an integer, because a factor of a number is a number itself, is another integer. You can do the same thing with a local variable. In this case, we have a local variable f. You can say local variable f is an integer. It can only be used to store integers. Okay, so that part is pretty easy. It's a fairly easy extension to what we already use in this class. We just have to specify when we write an algorithm, a subroutine. We just have to specify the type of every name that we use. So that's pretty much what the type is. Then we want to talk about records. Now, records is a little bit different. A record is also called a struct, also called a class in different contexts. And basically what it is you can make bigger things from smaller things, which is nice. Okay, so let's just use an example. What was the last paper form that you have filled in recently? Just give me an example of whatever form that you have to fill in. Any example? Medical form. Okay, so let's think about the medical form is a paper form. Okay, so on the medical form, it's on a piece of paper. Okay, the first question is, do you only have one single thing to enter on this entire piece of paper? Many things, right? Because most of the time you have your last name, you have your first name, you have your address maybe, okay? You have social maybe, you have the social security number, you have your phone number, date of birth, perhaps, depending on the form itself. Some of these are sensitive information, and some others are not. Many times, many forms now require also an email address, so people can contact you by email and so on and so forth. So let's just say that this is one particular form. This one single form has multiple boxes for you to fill, right? All of these are individual boxes. Okay? Does it make sense? I mean, everybody has filled in paper forms at some point, and these are what a form looks like. Each of these boxes that you have to fill is called a field. Okay? A field to fill in a form. Okay. Now let's think about this form and say, what if we don't have forms? Okay. If you don't have forms and you have to enter the same information, let's see what we can do. Let's cut this paper into slips of papers. Okay. In other words, we have one little slip of paper for every bit of information that you have to enter. We have one little slip of paper for your last name, one little slip of paper for your first name, one little slip of paper for the address, one little slip of paper for your social security number, one little slip for your phone number, and so on. Okay? What do you think is the problem with this approach? Instead of one single sheet, now you have a little pile of papers, each one containing just one particular item that you have to specify. What is the problem? From a practical standpoint, let's say you want to make a photocopy of your form. Okay? On a single sheet, easy, right? You go to the photocopier, put it face down, and press the copy button, and you're done. If I give you little slips of paper, what do you have to do? Each little piece needs its own copy, right? Okay, so it's cumbersome. What if you have your own pile of paper and then somebody else has his or her own pile of paper? You run into each other and the paper just flew everywhere. How do you know which slip of paper is whose? Well, you can probably tell, with most of these items because most of these are related to you. But if a third person wants to, make up the two piles separately again, that third person cannot do it. Because there's no way the third person knows, which last name goes with which first name, that goes with which address, and so on and so forth. So things can get lost, more easily when you do not have a single form, and instead you have these little slips of paper, each one only containing one particular field of the information that you have to convey. Is that making any sense so far? And this is what we have up to this point in this class. We have variables, okay, and each variable is one little slip of paper, but it is difficult for us to make up bigger objects because we don't have the concept of how to make a bigger object. To illustrate that concept, or the inconvenience of not being able to do that, let's go ahead and take a look at a program. And I'm debating whether I should use a spreadsheet to do it or just use text to do it. I'll just use text to do it for now. But I got to make sure I save this one too. And we'll just go ahead and define a subroutine to compare two dates and see whether the dates are the same or not. Okay? How do you represent a date? Month, a day, a year, month, day. Okay? So that makes sense. If I have to compare two dates, how many parameters do I need? 6. Because I have year, month, day of the first date, I have year, month, day of the second date, and then I can do the comparison, right? So I'll just go ahead and define the parameters like that. I'll pass by value, year 1, pass by value, month 1, and if I want to, I can indicate the type, okay? So they are all integers. By value, day of month for the first date. And then I have to copy and paste these 3. Remember what I say in this class, copy, paste, and modify is a bad thing. So that means I'm doing something that I should not be doing because I just did. Okay, I just copied, pasted, and modified. Okay. And the logic to compare to see whether two dates are exactly the same is pretty easy. Okay, because I just have to say return year 1 equals year 2, and month 1 equals month 2, and day of month of 1 equals day of month of the second one, and I'm done with this subroutine. Is that okay so far? There's nothing wrong with the logic of this subroutine, but there's a potential problem when I evoke the subroutine. Yep?
The problem with the return?
Sorry?
The problem is going to be with the return.
Why?
Because you're going to be returning numbers and you're going to be using int.
That's okay, because the parameters the type of the parameters does not have to be the type of the return. In this case, I'm returning a Boolean, which means the result of the invocation can be used directly in a conditional statement. Okay. Now, but if you think about the invocation, the first thing you would notice is it gets pretty long because you have 6 things to specify, right? Now, in addition to being very long, you can also make all kinds of mistakes. Okay, I can tell you some of the mistakes that people can make. They can use the year and the month of the first date, but accidentally use the day of month of the second date. They can use the year. They can basically flip-flop between these two. They can use the first parameter as the day of month, and then use the third parameter for the year. If people make those mistakes, do you think the programming language can catch those mistakes? No, because they're all integers. Okay, as long as those 6 parameters are all integers, the programming language will say, it's perfectly fine, not a problem. But with 6 items to juggle, the chances of a programmer making a mistake is pretty high. Is that making sense so far? It is basic. So this is equivalent to this analogy. Basically, you're separating each particular piece of item into its own field, and it has to be specified separately. Is that making any sense? Okay. So what we want to do is to say, let us consider a date as a composite from smaller items. So in that case, we have to use a record definition. So we say record, we are defining a record called a date. It is just a convention that when you define a record, you use a name that starts with an uppercase letter. So a date is made out of 3 different fields. The first field is a year, which is an integer. The second field is a month, which is also an integer. And the third one is a day of month, which is also an integer. And here's the end of this record type. A record in this class is also called a struct in C, which is also called a class in C++, Visual Basic, and most other programming languages. Okay, so I just want to make it clear the terminology are exactly the same thing. In other words, a record in this class is the same as a struct in a C programming class, which is the same as a class in C, in Java, in Perl, in PHP, and in Python. Okay, so these things are basically the same thing. And let me just add one more thing. It's also basically a template. It's not a C++ template, but it's basically a template, which you can also see as a cookie cutter. Okay, so we'll talk about cookie cutters and cookies later on, because that's a very important distinction. So if I were to redefine the equal dates, subroutine, now I can redefine it like this. I can redefine the subroutine, call it the same name, but this time I only need 2 parameters. The first parameter is D1, which is a date. The second parameter is D2, which is also a date. Oh, so that's what we can do with a record type. In other words, before we can only use the internal types that are defined within a programming language, like integers, booleans, and so on and so forth. But now that I have defined my own record called a date, I can also use that to specify the type of a parameter. Is that okay so far with this? Okay. And not only that, what do I do when I need to specify the return value in this case? Well, I have to somehow, designate, I want to compare the year of the first date with the year of the second date. And this is how we do it. The period is a very common notation used by just about any programming language to mean '(s). Okay? In this case, this means D1's year, D2's year, and so on and so forth. So the rest of it is pretty much the same thing. We have D1.month equal D2.month, and D1.day of month equals D2.day of month. Well, what is the difference between this version of equal dates? What is the difference between this and the earlier version? The number of parameters is only 1/3 of what it used to have. Okay? In other words, we are now starting to create forms. You can look at date as a very simple form. It combines 3 individual items into one single item. Okay? Now the second thing you have to notice in this case is the record type called date is a template. Okay? It is not an item. It is just a